In the previous video, we had learned about the basic idea behind the dual behavior of matter, and we learned about the de Broglie's wave equation. In this video, we are going to be solving 3 in-text questions. Let's start. What will be the wavelength of a ball of mass 0.1 kilogram moving at a velocity of 10 meters per second? So we know here we have been given the velocity, we have been given the mass. So from the de Broglie's wave equation, lambda equals to h by m into v, and h is 6.626, which is the Planck's constant, into 10 to the power minus 34 joules second, divided by the mass, that is 0.1 kilogram, into 10 meters per second. Now 1 joule equals to kilogram meter square second square. Okay, so we'll just be converting this joule to this, and that will give us so if instead of this, let me just write kilogram meter square second minus 1. It's minus 2, so minus 1, because you have joules second. Okay, so when we simplify this, we get 6.626 into 10 to the power minus 34 meters. So the wavelength is 6.626 into 10 to the power minus 34 meters. We just had to substitute the value of mass and velocity, and instead of using the Planck's constant in terms of joules second, we converted this to this, and then after simplification we get 6.626 into 10 to the power minus 34 meters. The second question, that is 2.13. The mass of an electron is 9.1 into 10 to the power minus 31 kilograms. If kinetic energy, that is Ke, is 3.0 into 10 to the power minus 25 joules, calculate the wavelength. First of all, we know kinetic energy is equal to half mv square. Okay, so from we have the mass, we need to calculate the velocity, so we can calculate lambda, which is h by m into v. Now here we know that kinetic energy equals to half mv square. So v will be equal to kinetic 2 into kinetic energy divided by m, that is the mass. So whole root, because it's v square, so we substitute the values. 2 into 3.0 into 10 to the power minus 25 joules, which is nothing but kilogram meter square second, minus 1, divided by mass, which is 9.1 into 10 to the power minus 31 kilogram, and whole of this is under a root. Okay, sorry for this. Let me just draw it again. Okay, now when this is simplified, so kilogram and kilogram will get cancelled, so you'll be left with meter square second minus 1, sorry, second minus 2, I'm so sorry. So when this is simplified, you get 812 meters per second. Now this is directly substituted over there, so lambda will be 6.626 into 10 to the power minus 34 joules second, divided by 804 mass into velocity, right? So 9.1 into 10 to the power minus 31 kilograms into 812 meters per second. This is equal to 8967 into 10 to the power minus 10 meters, or this can also be written as 896.7 nanometers. So we calculated the velocity from the kinetic energy, because k equals to half mv square, and we also calculated lambda from the values of h by mv, which is m was given to us, and we deduced the value of velocity from kinetic energy. The last one, calculate mass of photon with wavelength 3.6 angstrom. First of all, lambda equals to 3.6 angstrom. So this is equal to 3.6 into 10 to the power minus 10 meters. Okay, we are converting it from angstrom to meters. So technically, velocity of a photon will be equal to that of, velocity will be equal to that of the speed of light, which is c. So m equals to h by lambda into v, and we know v equals to c, so we substitute the values. 6.626 into 10 to the power minus 34 joules second divided by 3.6 into 10 to the power minus 10 meters into 3 into 10 to the power 8 meters per second. So when this is simplified, we will get 6.135 into 10 to the power minus 29 kilograms. So here we know that joules is kilograms meter square second minus 2, and we're basically simplifying it, cancelling the various so we are cancelling the units, and that in the end will leave us with kilograms behind. So here, instead of this, let me just do one thing. I'll write it in kilogram meter square second minus 1. So second minus 1 will get cancelled. Meter, this will get cancelled. Meter will get cancelled, leaving us with kilograms behind. So yeah, so with that we finish the 3 Intext questions based on the dual behavior of matter. In the next video we will be discussing about Heisenberg's uncertainty principle. Do check it out.